Hello everyone, this is Ali from Futurescape. I'm a lead application engineer over here. I've been working as a lead application engineer for the past couple of years in here, and I've been assisting our clients in various kind of simulation domain. And this is with regards to SimSolid, right? So it's an offering from Altair, and in this, it's a bit different than the traditional FEA that we have, right? It's much more faster than that. So in this presentation, basically, I'll start with the PowerPoint presentation that might last about 10 to 15 minutes. Post that, I'll jump into a demonstration of the software and show you how it works and how you can simulate different kind of weld conditions within Altair SimSolid. And between the session, we'll have a quick question and session round. And in the end as well, we have a question and session round, right? So if you have any questions, please feel free to write in the chat box or in the Q&A session. Aarti in here will be in the end letting me know what all questions you have, and I'll be assisting you with the same, right? So let's quickly go ahead and I'll just share my screen. So in this webinar, basically, we'll be focusing more on the welded structures within Altair SimSolid, but I'll also give you a brief overview what Altair SimSolid is and how it's different from traditional FEA softwares, right? So begin with, so Altair SimSolid operates directly onto the original unsimplified CAD assemblies, which doesn't require a traditional finite element mesh, right? So if you have a solve, if you're doing a traditional FEA, first of all, you need to clean up that model a bit. Then you need to generate the mesh, then insert the boundary condition, and then do your simulation and all those sort of stuff. And this thing can take a lot of time, as you might understand, if you have done any kind of simulation. So it takes a lot of time even to just clean up the model, then go to the mesh generation and ultimately solving it. And you find out there is some error in the solve. You go back and again check your mesh and do all kind of thing again and again, right? So it's very slow in that sense. But within SimSolid, it's really fast because it doesn't require to create the mesh, right? It works directly on full CAD and can generate high fidelity connections. And as mentioned, no mesh is required. That's why the result is in within minutes, right? So in traditional FEA, what you have a CAD model, you generate a FEM finite element model of that, and then you get the results by applying the boundary conditions. In SimSolid, the whole body is taken into account, so you need not to simplify it. You need to remove, screws and all those sort of stuff. If you want, you can do so. But SimSolid is very advanced in a sense. It has AI algorithm. It automatically detects what kind of objects you have within your model, and it defines those objects accordingly, right? So if you have a nut or a bolt, it automatically assign a nut or a bolt kind of properties to that very solid. And that's why, because you need not to create the mesh, it's really 25x to 100x faster. So I'll show you basically within this demonstration, we'll set up a model from scratch and you'll see in front of you how fast the solve is, right? Within couple of minutes, model can be solved and you can extract the result out of it. Not just that, it is capable of solving very large models as well. As you've seen here, this has about 2,162 parts, and uh, it is solved within couple of minutes or so, right? Even SimSolid doesn't require any kind of high specific hardware. So on a traditional system, which has just 2 GB or 4 GB graphic card, and simple system, this i7 system or i5 system can run this software, right? Do not require a heavy hardware to run SimSolid as well, right? Again, you have assemblies, you have features that you need not to remove. Even if you have parts which have gaps, overlaps, even penetration, that can also be solved in here. Moving on. So how does it does all those things without creating a mesh, right? So that will be first question that will come onto anyone's mind who is looking after for something like SimSolid, right? So what it does basically, the AI algorithm first of all recognize what kind of part or what kind of feature it is, right? And create initial set of equations. Now, instead of dividing the whole model into small part, it takes a few components and treat that as an object, right? And solve complex mathematical equations for that set of a body or the part. Now it calculates the error in the very next step. So first step, it does that. It calculates the error by applying the mathematical equation on that very body. Instead of creating very small patches or very small surfaces or mesh, it takes a very large amount of body or object. It creates solves the equations, and then it finds few errors based on what our tolerances are, right? Now, it senses where the error of displacements or forces are a lot and try to adapt and basically divide the parts into multiple fractions and insert more degrees of freedom so that basically, as you see in here, so it inserts more degree of freedoms and constraint and connection so that the analysis is bit more optimized for that. Again, it go and solve it and calculates the error. Again, if the error is a lot, it again goes on and does for 3 or 4 times, and then it shows up the result. Right? Now, as I mentioned, the speed and all is quite fast. If you have basically, as you see in here, it has 1180 assembly parts, and from CAD to setting up the result, it's about 10 minutes and 29 seconds, right? So it's really fast because of non-creation of a mesh. Now coming on to the main part for which in this webinar we'll be majorly focused on, that's called connection or welded connection. But first of all, why do we need welded connection? Why not the simple connection? So basically, simple connection will join and have a bonded kind of a property along the cross section. And as you might understand, we do not glue parts together, we weld them, right? So it might not represent the true behavior of how the component will behave a in a realistic scenario, right? So weld is something if we have on our model that will be really give us a really good interpretation of the results. So what we'll be doing, we'll be setting up a model and we'll be doing the weld creation in here. And in traditional FEA, it will be quite typical to create weld and all. But in here, we have smart features through which you can just quickly, within a minute or two, you can just create the weld connections and join these parts, right? So in general, we'll talk about three welds in here, three kind of welds. First is the spot weld, right? Second is the laser weld, and third is the seam weld that we'll be talking about. Mostly we'll be starting with the seam weld, and then we'll be ending with the spot weld. Now, these welds are created in such a way that these are assumed to be perfectly bonded, and the dimensions all we can insert when we'll be creating the welds of these sort, right? So let me just skip this. Okay, so laser weld, and then we'll be creating the seam welds. Now, there might be a concern in terms of yeah, it's really fast, but there will be something that will be missing out in here, right? So yeah, we will be missing out the basically the results accuracy, right? Because it's much faster than traditional FE8, it won't give that much good result, but again, it's not that bad. So as you see in here, so I have in here a table wherein you can just see what's the discrepancy in terms of different kind of results that we have performed within SimSolid. Usually it might vary, 1% to about 10%. in terms of what kind of simulation that you're solving within SimSolid, right? Based on that, basically, the results can vary. All right. So moving on, we are good with the presentation. Now let's move ahead with the software demonstration. I'll just quickly go ahead and again share my screen with the SimSolid window. Right. So this is SimSolid interface. So it's very classic in a sense. Basically, do not have multiple ribbons. It's quite simple to use as well. So I can just go in here and just insert my CAD body from the project side. So I can just import a file. Again, we have a different kind of uh, CAD file that we can directly import in here, right? So if you have a SimSolid file, SolidWorks file, if you're importing from UGNX, right? Even Inventor, you can directly insert your files in here. But I have preset models that I have with me as of now. So let me just go ahead with those models for now. So let me just open that up. Okay. So let's start with the first model that's called a welded frame, right? So all the menus will come up in here. We have two toolbars, one horizontal and one vertical toolbar to set up, even create different kind of connections, even have different kind of boundary conditions as well. On the very left side, there is a project tree wherein I can see and monitor all the different aspects of my projects, right? So within the assembly, if I go, as I mentioned, right? So the software automatically detects what are the different kind of objects that I have in here. So for example, which one is sheet, it automatically determine that, and you can see the details in here. But for now, we are not concerned about that. We are concerned about the connections, right? So as you see, this is the frame, and we might need to weld it, right? And creating weld one by one, it will be quite typical to create the welds, even simulate them, and the meshing will be another, big task to do. Uh, Within SimSolid, what you can do, first of all, you can create automatic connections. So what do I mean by automatic connections? So basically, I just click in here and a dialog box open up, and it asks me basically what is the tolerance for the gap or the penetration that I'm looking for. So that's the reason you need not to clean the geometry that much, because based on these tolerances, it can automatically create the connection for you. So in the very early stage of the design, you need not to be that much accurate. You can just try and test your design, whichever you have. Just put in SimSolid, enter the data, and see how the part might be performing. Later on, you can refine your models and see which one works best for you. For initial stage, you can just come in here, take the model. Let's say 1 mm is the gap, 1 mm is the penetration. I click OK. It goes ahead and it creates the regular connection in here, right? So let me just take one sort of a connection. So this is the connection that it has created. And you might see, as I mentioned, it has created the connection on the cross section, right? This is not the real behavior that we are looking for, because we are not gluing these things up. We are welding these things up, right? So this might not be a correct representation. So let me just keep this as it is. And let me have another load case scenario or another design study that I'll be solving. Let me just copy this and just delete all of these connections for now in this design study. Now we are good to start setting up our welded connections. So I have different kind of connections ribbon in here. So I want to create a spot weld, a seam weld, or I want different kind of virtual connectors. For now, we are just looking for welds. So let me just go to a create new seam weld. Now a pop-up will come up, and this pop-up will ask me what is the section size and the length that I'm looking for. Let's say I'll keep it by default like this. And let's say I'm looking for to create weld between these two components or these two parts. So I just select this as a primary and select the secondary one. The other one is secondary. I can just click on find welds. The software will go ahead and see wherein it can insert the welded. Right. Sorry. So if I'm good with it, I can just click OK. It will go ahead and create that weld for me. Right. So a seam weld is created. As really easy as you might see, I just selected two parts and it created the weld for me. Again, if I just have a different component, let's say I just want between these two in here. Again, I can just go in the connections, select the primary part and the secondary part. It will show me there are two welds that are detected. And just zoom into these welds. First is this one, and second one is here. Right. So I can just again click OK, and we create the weld for me. But you might say that this is also a difficult task. I need to go ahead and create all the welds around. This again will take a lot of time to me. Not as much as that you will require for ICA, but again, this will take a significant amount of time, right? So let's not create this one by one. Let's create this automatically by selecting all of these parts. So again, just go in here. I just go to something called a group weld, right? I just select all of these parts, right? Click on find welds. I will go ahead and see wherever this can create the welded connections. As you might see, all these uh, components, it have attached all these bodies to the other ones. Now I can see what these welds are. I can zoom in. In total, there are about 213 welds that have been created in here, right? If you are good, I can just click on OK. And within a couple of seconds, these welds will be created. You just click in and you can see all these welds in here, right? If I just want to delete any of these, you can just zoom in and see where it is. And I can delete those welds or just modify them or whatever I want to do basically. Now, let's say I just wanted to check if there are any part that's remaining. Let me check. Yeah, so there are no disconnected parts as of now. So I guess I'm good with my initial setup, right? So here and now I can just go and solve this and see what the results are for all of these. So as I mentioned, I have two of these design studies. One wherein I haven't uh, added any of the welds, so I have a regular bonded connections for all of these solids. And the other one wherein I have added these welds and uh, these welds are shown up in here, right? So I can just go ahead and just click a solve. And before this, again, I need to set up a boundary condition. So we have a different kind of solve that we can have. So we have basically a structural analysis if I want to do. if I'm into model or something, or a dynamic analysis can also be done within SimSolid. Or if it's a thermal, right? So it's a structural linear analysis, and we have inserted two boundary conditions. Uh, First of all, we have immovable supports in here, and we have added uh, some force in here as well, right? So these are the two conditions for both of the design studies that we have applied. Now I can just go to this project and just click on solve. Yeah, I just want to solve for all of these. Just click solve. Now in the bottom, you can see that the progress has started, right? So initially, as I mentioned, the very first step, what happens basically, adjust the parameter. It applies the equations in all of the body, whole of the body basically, instead of dividing into different mesh sizes, and then it goes on to repeat and try to see if it's able to decrease the error. And once the error is below a certain mark, it shows us the result. So currently it reaches to pass 3, and again it's again solving and analyzing the connection and reach to pass 4. So at minimum we can have about 3 passes. We can have maximum of 6 passes in here. But the solve can automatically determine that based on your conditions. By default, it takes about 3 to 4 passes to give a good results, right? So more passes doesn't mean that it will give you much more better result. It might have basically much more noise around the connections. So basically 3, 4, or 5 is a good number to start with. Even the software suggests which one is the best one for your kind of a solve, right? So before we move on to results, I just saw that someone was raising the hand. So yeah, please feel free to ask your question, unmute yourself, and I'll take few questions right now since the solver is trying to solve for our current problem here.
Yes, my question is, between the tubings, there's sometimes when you have a good connection, it will create a good weld. But when there's an around or a corner or a fillet or anything, it doesn't create the weld between the two tubing. How can we add this one? Like if you go
The,
on two beams on the top,
Mhm.
it
Yeah,
just created like a part of the welding. It's not an all around. Let's say
yeah,
not yes, this one. You see there's a missing one there.
got it. Yeah. So totally correct. This is a really good question out here. So let me just share you something in here. Just give me a moment. Yeah, so SimSolid in most of the cases will create the weld, but in some of the cases wherein the surface is not proper, in very few of the cases, it might not be able to create those welds, right? In that scenario, basically what option we have, let me just share it with you right now over the screen, just a moment. This is a really good question. So I have a specific sheet in here. Can you see my sheet in here? Can you see the PowerPoint? Okay, so there's some kind of welds that cannot be created, right? So there are few cases that SimSolid might not be able to create welds. These cases are where there are convex edges or overhang, or there are fillets, right? So in this case, what we have, basically the workaround that can be done is you need to create a CAD geometry within the CAD environment, And within SimSolid, you can simplify that as a CAD, as a weld. Right? Just after this solve, I'll show you one of the model in which I have the similar scenario, and how I'll create the weld in that case.
Good. Thank
Right?
you.
Thank you. I mean, that's really good question and a bit more technical. I need to push a bit for this. Like, yeah, I'll just show you how it's done in the very next example that I have. Okay,
Excuse me, sir. We
let's
have another question in chat section. Could you please check it?
let me just check it. Definitely, George. We'll send you the presentation. We'll send you a link to replay this, and as well as a transcript file and the certificate if you want. That's also a possibility, right? So we'll reach out to you post this webinar and assist you with whatever you require from our.
Sir, it's in chat section from Mortesa.
Okay, it's in the chat. Okay, so Matilda asked a really good question. What are the material properties defined, and where did you define those properties at? Uh, really. So I'll show you. Basically, it's just going through the solve. Let's just wait a bit. So basically, in here you have the material library, right? So from where you can basically determine or select the material that you want to imply or apply to your specific case, right? So inbuilt library is there for the materials that you can choose, or if you want, basically you want to create a your own material, that's also a possibility in here, right? Let me just open another session for you to quickly show that up. And just wait for this to complete.
I was just wondering, can you also edit the welding wire which you want to use for your welding simulation? Like, because we use different welding wire for different strength of materials, right? We can change the material, but how about the welding wire? Can we update that as well as we require?
Basically, the material of the weld, you mean to say?
Yeah, the welding wire, because welding wire has different properties, different welding wire,
Metal
right, based on
properties.
the designation. So, and we usually it is expected to use welding wire which matches the strength of the base material, right, for better life. So, if we want to do simulation, can we update the welding wire if required for our simulation? Suppose we go from a low strength material to a high strength material, then we need to change a welding wire as well, right? So, how do we incorporate that in the simulation?
Sure, there's a way to do that as well. I'll show you that one.
All right, thank you.
Before that, yeah, you're welcome. So before that, let me just show you the material library. So you have built-in material library within SimSolid, wherein you have some generic materials. Even if you want some sort of alloys, those are also present in here, right? So by default, I've just applied a steel in here for all the bodies in here, but I can selectively apply the material as well, right? So within the assemblies, I can selectively apply if I want, or if I want, I can apply to all at once as well.
Okay,
You
thanks.
right? Even if you want to create your own material in here, that's also a possibility. You just want to copy one material and create another one from the baseline of the earlier material. That's also possible in here, right? So coming on to the other question that we had. So apply material to seam weld, right? So if you want to apply material to the seam welds, so it won't be coming in the assembly. Reason being, these welds are not a CAD components, right? These are differently created by SimSolid, right? So you cannot apply the material to these welds within the assembly. So within the seam weld, you have an option to apply material to seam welds. Again, here you just have a material library. You can just select which material you want to apply to these weld. Or and again, you have both the options that if you want to apply this to all the welds or you want to apply to the selected welds. Right. Both the possibilities are there. Right. I guess I answered both the questions. No. So herein within the weld analysis, HZ or heat affected zones, as much as I am aware of, it's not considered.
That's okay.
Again,
Thank you. I was just curious.
you're welcome. It's a good question. Again, I can just check with uh, Altair tech team on this to see if in future they have a possibility of having that kind of simulation. I'll get back to you on this one.
Okay. Thank you.
Right? You're welcome. Okay. So we were able to solve, and in front of you itself, I just solved, and I can just go to the info and see how much time each of the solve take, right? So wherein I do not have any kind of a weld, and I just quickly just move on to the solve. So it takes just around 1 minute and 33 seconds to solve structural analysis of solve, right? If I just come for the welding, it takes slightly bit more. So it takes about 6 minutes and 45 seconds, right? So just 7 minutes, I was able to solve this. Now let's go ahead and see what kind of results I can get out in here. So I can see what the displacements are, right? All right, can you see now?
Yep.
Yes.
All right. So basically, I was showing that in here, if I just go to the info, I can see what's the total time run. So this is the total time run in case I was not having the welds. It was purely bonded connection that I had. So it was really quick, just 1 minute and 33 seconds, right? In case of wherein I had a seam welds, it takes slightly longer, but not that long, I'll say. So it takes about just 6 minutes and 45 seconds to solve that up as well. So it's really fast, as you might understand, right? So now let's quickly go ahead and see our results. So let's start with the displacement first. So this is how the displacement is varying. I just have an animation if I want. And within the legend, I can see how all things are varying, right? So displacement can be seen in here, how my shape is getting deformed, all those things can be seen in here. And based on that, I can interpret the results, basically. Coming on to the stresses, again, we have option for checking the stresses as well. So for the one Mises stress, you can see wherein what all regions I have a lot of stress and wherein there is very minimal amount of stress. I can even pinpoint which is the maximum one and where are the minimum zones that I have within this. Right? And see how it's formed, right? I can see similar with displacements. Now side by side can compare. So without wells, the maximum displacements was going somewhere around this because it hasn't created the connections in here, I guess. And these connections were not created, reason being the gaps and the penetration that we selected was not proper, right? So these were either the gap was more than 1 mm or the penetration was more than 1 mm, because of which these connections were not connected, right? Now let's see regarding the welds that we were exploring in here. So we have weld forces. Just go to the seam weld and see what sort of forces each of these weld is going through. You just click on evaluate. You can see what kind of force it is going through, and even I can see the reaction along this. So let me just move it to the side. And let's just go in here. So you can see how this weld, the reaction is varying on this very well. Right. So I can save this graph as well as a PNG or as a TXT or a PDF file. Even I can have stresses. So these are the forces and momentums. I can have stresses in different welds. Again, I can just click on evaluate in here and I get all the information for all of these welds. I can export these as a file, again a CSV file, so that I can see which of the welds are having significantly higher stresses and which one is having significantly lower stresses. And again, I can just generate the reaction on these welds as well. Now, this was the case in which we had seam welds, right? What if I just do not want to create seam welds, or we have different kind of problem? Or the question that one of you asked, that let's say it is not finding welds in some of the regions, right? So what to do then? So in that case, let me just open my another project in here. Just this one, right? So I'll open another project in here and show you basically in that scenario wherein do not have uh, uh, the weld created, how you can insert the weld. So I'll just open my project. So let's just open this one up. Okay, so this is a thin sheet metal, I'll say, with different components. Let me color these different components with different colors. So first of all, again, so I can just go ahead and in the assembly, I can just apply the materials in here. Let's say I'm looking it for a steel or something of that sort. Can apply to all the parts and just close. Right. Now, in this case, basically what we have done in some of the cases, as I mentioned, right? So we do not have the capability within SimSolid in which the weld will be created. So what we have done from the CAD interface, we have inserted some of the welds itself, right? What we need to do, we just need to name them as welds, right? For example, you get see it's a fillet weld. Let me just zoom into this one. Right, so this is the weld that has been created in here. The software might not be able to create it, so I've created this in the CAD interface. Now what I can do, I can just go to the same old way. Just go to the create new seam weld. Herein we saw that you can weld one by one, you can do by group, even you can do by edge. But I'm interested by creating via the solids, right? Now in here, I can just find the part by keyword. So all those welds that we have created in the CAD will name it by weld. Let's say you can give another name as well so that it's easy to filter out. So I have filtered out all those components which are by weld, right? And I can just select all of these in here and just click on find welds. As you might see, the software automatically recognized these and has shown you that what all welds it can create out of it. Okay. Just click on OK. Now these geometries will be auto converted to welds now. seen here. So these have been inserted as welds. And herein as well, you had welds. So I guess we had a question in the past, in the case wherein the SimSolid is not able to create welds, we can insert the welds from the CAD at the time of design. So first we design the part, we take it to the SimSolid, we see wherein it was able to create the weld. If it's missing weld somewhere, we can get it from the CAD itself, right? So you do not have CAD operations within SimSolid. It's just pure simulation that you have in here.
And it
Right.
have to be a round, like a circle, or you need you're not cutting like to a quarter. It's really a full round, a full circle when
Yeah,
you
so
create
it
from
need not
solid.
to be. Yeah, so it can be seam as well. So if I just delete this, so let me just delete all these wells. It deleted the part as well. Let me just open that again. Right. So as you might see, right? So whatever the shape it is, it will create the weld for that. So this is a fillet kind of a thing, right? So it will create the weld. Only thing we need to do is, we need to apply that uh, a name so that we are able to filter that out easily. Let's say putting weld in all of these names. So if I just go to the assembly, or let me locate this in the assembly tree, right? So this is the part in here, and you have the welds in here created, right? So even in here, if you go, right, so find this in structure tree. So it need not to be circular, basically, because if you see, there are seam welds which are not circular, which is in a kind of a fillet, and again, it's able to create the weld.
Okay, thanks.
You're welcome. Now, let me just go back and just again create seam welds. Let me just right. So I'll just again repeat those steps. Create the welds in here. Right. So as I mentioned, right. So you need to mention the weld. So during the CAD operation, the CAD guy might have missed mentioning this as a weld. So this is not included in this, right? So it's not created as a weld in here. I can just check if the geometry is disconnected or connected. It's disconnected, right? So we have different ways as well. So let's say I want to create spot welds. So within the spot, I can either, select the spots that I want to create, right? Point by point. Or let's say just we can have a CSV file wherein we have all the information about the welds where we want to create. And I have a CSV file in which all the details are present and will all at once will show me what all locations are there. And I just click OK, and those welds will be created in here as well. Right. So let me just quickly go ahead and set up a simple kind of a solve. Let's say structural linear analysis. And we want to give, let's say, movable support on the top. And for now, let's just apply gravity as the load. So it will be in minus X direction. Right. So I just click OK. And I just click confirm. So some of the parts, materials haven't been assigned. So let me just assign those materials. So steel for all the parts. And let's go ahead and solve this. So again, it showed me there are certain disconnected components. So what we do in those cases, basically this is a third case scenario. Let's say uh, with the welds, it's not able to create. We have something called the connection wherein it won't involve the weld, right? So we have something called connect unwelded parts only. Let's say we have connected some of the parts with welds and other parts we do not want to connect via the weld. There's something called connect unwelded parts. In this case, I'll just come to connect unwelded parts, right? So it will leave all the welded parts and just connect those which were unconnected. Let's give a solve now. And now within couple of seconds, I'll say, in this case, we'll get out the results which we want, right? So again, you have the displacements and you have the stresses. Similarly to what we had in the past, we can just go and see the different kind of, let's say, for the spot welds, what are the kind of forces that's acting on the spot weld, right? So different spot weld, I can just one by one see what kind of forces or moments that are acting on those spot welds, and I can save that to a CSV file. I can take it out and save it just for uh, my sake or just for the presentation purpose. I can take it out as well. Again, you have those seam weld reactions that we saw in the past. I can just evaluate one by one and see what kind of moments or forces are acting, even what kind of stresses are acting on each of these welds. And again, can evaluate the results that we have in here. Right. So how are the reaction forces varying along the length of the weld, basically. Right. So as you see in here, right, it's really easy interface that we have in SimSolid. It's quite intuitive. You have a steps to follow and you get out the results. Generally, you do not get stuck much, but again, there are some limitation as one of the user asked that in case it's not able to detect, in that case, I can just go back to my CAD assembly and create a weld from there itself, or I can just leave that as such and just for the time being, I can just create those as a bonded connections, right? So different kind of things can be applied based on the problem statement that you have in your hand. Again, if you want much more accurate results, creating more wells wherein the wells are there will be much more appropriate than leaving them aside, right? So there's a personal choice, what you want to go, or you want much more accurate, or you just want a simple results out and see and then just iterate your design. That's totally on to you, right? So that's all in terms of what I just wanted to show today in here within this quick presentation. Now, again, if you have any further question, I'll be more than happy to assist you with your questions. Before you wind up, please make sure that you give us a feedback because we'll continue our series of different softwares and different applications that we have within Altair, even SimSolid, Altair as well as ANSYS. So, Aarti, if you don't mind, can you please push the feedback form in the chat so that
Sure, sir.
our participants can just fill this and give us a feedback, even comment on what they would like to have in the future. And again, in the meantime, I'll be having questions. If you any of you have questions, please feel free to ask. I'm here to assist you for the next 8-10 minutes more.
I had one case where I was putting an intermittent weld,
Mhm.
and I was getting a weld from as normal, but sometimes at the end of the weld, since I was not able to have a full length, it was not showing that normal.
Mhm. Mhm. So you already have SimSolid software?
Yes, yes, I'm using
Okay,
it.
all right. Okay. So, will you mind sharing that model to me? So it shouldn't be the case, but again, I can specifically, if you can just share me the pictures or if you can just forward me the model, I'll be more than happy to assist you with your use case, right? So it shouldn't happen that way. It should be there if you are creating the intermediate weld, or again, there will be something going wrong. In that case, you can just go back to CAD. But again, if I'll be able to take a look at the model, I guess that in that case, I'll be better be able to comment on that problem statement. Yes.
Yep.
Right. So I'll just drop down my email address in here. Feel free to just uh, connect me over there, and I'll assist you as best as possible. Right. Even if any one of you would like to try SimSolid out, we also can assist with the trial of SimSolid. You can just have a look at it for your use case. And if it feels interesting to you, we can discuss further regarding training and all those sort of stuff, right? So for SimSolid, you do not need that much time to learn. Traditional FEA, it's a lot of stuff, right? You're cleaning up the geometry, you're creating the mesh, you're understanding about the boundary conditions. But again, that's much more accurate. But if you have really little time in hand and you want to just get out the results as fast as possible, something like SimSolid might be of interest to you, right? So we have customers, basically those who are not able to simulate, even able to simulate, reach to that position of getting the simulation done because of the mesh creation part, right? And they're finding SimSolid really useful in that case. Even we have dynamic simulations as well. So in future series, we might show you much more advanced features of SimSolid. But again, for now, this is it. And again, we are open to more webinars in the future. Just let us know in the comment section or in the feedback form that you'll be filling what all you'll be interested in. We'll be more than happy to, you know, go on to go on and push ourselves a bit more and get out much more better niche topics which you guys will be interested in. Right. Any other question that we have in here? Matthew, you have really, really good questions out here, I guess, because you're already having SimSolid and you experience the problems. That's why you're able to state those problem statements, right? Yeah, so everyone will be getting the presentation. Everyone here will be getting the recording of this webinar, not at all an issue. Even if when someone wants a certificate, just send us the details out there with your name and we'll let you know and we'll send across the certificate for this webinar as well.
Thank you.
And you're welcome, Matthew. So I'll be waiting a bit more. And if you again have any questions, let me know. We are here to assist you with your questions. I guess we are good for now.
Yeah, thank you very much for the presentation. It was very helpful. Thank you.
You're welcome, Mr. Nayak. So kind of you. Thank you very much, guys. Take care. Have a great day.